Alright, monomials and polynomials. Students will be able to multiply and divide monomials and polynomials and add and subtract polynomials and use expressions written in scientific notation. Okay, a monomial. This is an expression that is either a number, a variable, or the product of a number and one or more variables. So here, number multiplied by several variables here, 3b's actually, so negative 5 times b times b times b. So that's an example of one. These are not examples. Anytime you have it in a square root or you have a variable on the denominator, those are not monomials. Important to remember that. A constant, these are monomials that contain no variables. A coefficient, this is the number that is being multiplied by a variable. So for example, here we have 6x. 6 would be the coefficient, or up here negative 5 would be the coefficient. Alright, so just some terms that we got to have down. Now let's talk about a couple things. Let's talk about what negative exponents mean. Negative exponents just mean that you do the exact same thing as a positive exponent, except for it flips. It's the reciprocal. So this is the same thing as 1 over 2/3, or 2 to the third. And 2 to the third is 8. So this is actually 1 over 8. That's all these mean. So what do you think it means if it's on the bottom? Well, it just means we move it to the top. So this is just the same as x squared. That's it. And once you guys do this one on your own real quick, I'll put the answer up here. Hopefully you get it. You should have that it's x to the 5th over 5 squared is 25. Okay, not too bad. Alright, let's talk about adding and subtracting exponents. So what is 3 squared times 3 cubed? Well, let's think about this. 3 squared is really just 3 times 3. And 3 cubed is really 3 times 3 times 3. Well, if I have 5 3's here, isn't that the same thing as 3 to the 5th, which I believe is 243? And look what the shortcut is. 2 plus 3 equals 5. And that'll always work. You can just add the exponents as long as the bases are the same when you're multiplying them. So let's go to this one. X squared times x9. What do you think the answer is? You should be able to just do it in your head. It's x11. And if multiplying means that we add, what do you think it means when we divide? Well, let's take a look at what it really looks like. This is really saying 5 times 5 times 5 over 5 times 5. Well, sure enough, some of these 5's are going to cancel out, and we're going to just be left with 1, 5. Well, this is the same thing as doing 5 with the power of 3 minus 2. See, so you could just subtract 1 from the bottom. 3 minus 2 is 5 to the 1, or just 5. So when they're dividing, you just subtract. So try this one. You guys should be able to see it right away. 13 minus 7 is y to the 6. Okay. That was all adding and subtracting exponents. Now let's put it all together in a problem like this. I have this term times this term. We're just going to do the numbers, the x's and the y's, and just rewrite it because we can't really do much else. So 3 times negative 4 is negative 12. X cubed times x squared is, remember, we just add the exponents, so that's x to the 5th. And y squared times y 4th, add the exponents, that's y to the 6th. And that's easy. We just took something that looked really nasty. Sorry, I wanted to use my laser. We took something that looked really nasty and solved for it, no problem. So I want you guys to do practice number 3 on your own real quick. You can pause the video if you want, because I'm going to put the answer up in a second. Okay, negative 2 times negative 5 is 10. A fifth times a squared is a 7. And b squared times b fourth is b6. And there you go. Alright, when do we multiply the exponents to each other? Well, let's think about this. Here I have a to the 3rd to the 6th power. Well, what is this? This is like a to the 3rd times 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 a to the 3rd. Okay, remember we said we could add exponents, so 3 plus 3 plus 3 plus 3 plus 3. Well, that would give me 18. So this is the same thing as a to the 18. Well, anytime you have a power to a power on the outside of the parentheses, you can just multiply. So this is the same thing as a times 3 times 6, which is a18. And there we're done. So let's try this next one. You guys should be able to catch on. First, we're going to do negative 2 to the 5th power. I want to stop and talk about something here really quick. Quick little rule. Anytime you have a negative to a odd power, the answer will be negative. But a negative to an even power will be positive. Let me show you why. Let's just do negative 2 here real quick. Negative 2 to the power of 1. Well, that's just negative 2. Negative 2 squared. Look, that's going to turn into a positive 4 because the negative times a negative. I should put parentheses around here, by the way. Negative 2 cubed. Well, that is negative 8 because negative times a negative times a negative makes it negative again. And then negative 2 to the 4th, that's going to be positive again because it's negative 8 times negative 2, which is positive 16. And then lastly, negative 2 to the 5th is a negative 32. Okay, so over here, we just got to keep track of when it's going to be negative or when it's going to be positive. So over here, I got negative 2 to the 5th. That's going to be negative 32. And then p third to the 5th, it's going to be p 15. And then s squared to the 5th is going to be s10. Okay, why don't you guys try C on your own. Actually, let me start you off and tell you that you could do this. You can write negative 3x to the 4th over y to the 4th. You could split that exponent up on the top and the bottom. And see what you get when you simplify that guy out. Alright, hopefully you saw negative 3 to the 4th power. That's going to be a positive because it's a negative number to an even exponent. And negative 3 to the 4th power is 81. So this is positive 81. And x to the 4th over y to the 4th. Now I got this question a lot. If I distributed this 4, why is it still there? It's not really still there for the 3, for the negative 3. We already did do that to the 4th power. But we can't really do anything to the x other than write a little 4 there because we don't know what x is. So that is as simplified as we can go. Okay, try D really quick. Remember, it's a negative exponent. If you're totally stuck, remember this means it's going to be 4/3 over a/3. You could split it. And 4 to the 3rd power, 4 times 4 is 16, times another 4 is 64 over a/3. There you go. Okay. Let's put it all together. And let's do practice number 5. Now, this is interesting. I'm going to walk you through the first step here. Remember, we're just going to distribute this 4 through to every term. So this is negative 2 to the 4th power, which we already learned over here is positive 16. And x to the 3n to the 4th power. A lot of people are like, oh, what do I do? There's a 3n there. So what? All the rules are the same. Remember, I just multiply. 4 times 3n is 12n. So 16x to the 12n over x to the 2n times 4 is 8n. And y3 to the 4th, that's going to be y to the 12th. Okay. I have an x to the 12n here, x to the 8n here. They're the same base, so I can subtract exponents. 12n minus 8n is 4n, so the answer here would be 16x, 4n over y to the 12th. Okay, that's it for this page. Let's go on to the next page. Okay, let's talk about scientific notation really quick. This is something you guys should be familiar with. Most of you guys are already doing this in science class. It goes in this form. A is some number times 10 and n is your power. But you want to do this when a is between 1 and 10. So we convert a big number or a really small number into this format. It just makes things a little bit easier to deal with. So for example, I got this big number here. Well, I can move this decimal place over 1, 2, 3, 4, 5, 6 spots so that I actually get 6.38. But to note that I'm going to make this, that the real number is a lot bigger, I'm going to multiply it by 10 to the number of exponents that I moved the decimal over. Well, I moved it over 6 spots and I got 6. And this is positive. I'm going to have a positive exponent here because the number that I just used is bigger. than my number that I have here. That's kind of the rule of thumb. Let's do practice number 5. You guys should be able to do that one on your own really quick, but remember you're moving in the other direction, so your exponent should be negative. Okay. 1, 2, 3, 4, 5 over. So you get 4.7 times 10. And since you went 5 to the right, it would be negative 5. And it's negative now because the number that we had before is smaller. Okay. And this makes sense too if you think about what this means. What does 10 to the negative 5 means? Well, it means 4.7. Move the 10 on bottom, right? 10 to the 5th. Or 4.7 divided by a 1 with 5 zeros. And that's how you would get a decimal, right? So that's how you get this really small decimal. Okay. So let's talk about multiplying scientific notation. Here, 2 times 10 to the 5th times 4 times 10 to the 7th. Well, what you can do is you can rearrange this. So you get 2 times 4 and 10 to the 5th times 10 to the 7th. You're allowed to rearrange things when you're just multiplying them. And so 2 times 4 is 8. And I guess we usually use an x with scientific notation. And 10 to the 5th times 10 to the 7th is just 10 to the 12th. And so there we go. That's why if we know the rules of scientific notation, it's really easy to work with, figure out these numbers. Why don't you guys try this on your own real quick? See what you come up with. I'll put the answer up in just a second. Okay, so I rearranged it. So I did 2.7 times 3 and 10 to the negative 2 times 10 to the 6. 2.7 times 3 is 8.1. And 10 to the negative 2 times 10 to the 6 is actually 10 to the 4th. Alright, there we go. Okay, let's read this problem. It says after the Sun, the next closest star to Earth is Alpha Centauri C, which is about 4.4 times 10 to the 16th meters away. How long does it take from light from Alpha Centauri C to reach Earth in years? The speed of light is 3.0 times 10 to the 8 meters per second. Whoa. Okay. This is a dimensional analysis problem, and a lot of you guys who are in chemistry, you're already doing this, and if you got a system that works, then just keep using it. Ignore my way. It's fine. I'm just going to tell you how I like to solve these problems. I like to start off with the unit that I'm going to end in. So I know they want my answer to be in years, so I'm going to start off with year. And I'm just going to ask myself, well, what do I know about years? And keeping in mind that I'm going to have to somehow get to meters and seconds and meters here. So what do I know about years? Well, I know that in 1 year there's 365 days. And if I wanted to get real, I could probably say 365.25 days, because that's like a solar year? But that's not really that important. Okay, so 365 days. So now what do I know about days? Well, I know that for every day there's 24 hours. And what do I know about hours? Well, for every hour, 1 hour, I'm going to have 60 minutes. And for every minute, I don't know why I keep writing that wrong. 1 minute, I'm going to have 60 seconds. Okay. So now look, I finally got down to seconds, and look, I have something with seconds here. It's telling me that I have 3.0 times 10 to the 8 meters for every second. Well, the whole point of doing this is to get your units to cancel out. So if I have a second down here, I want my 1 second to go up here. And then I'm going to put, since 3.0 times 10 to the 8 meters for every second, I'm going to put that on the bottom. Okay, and that's meters, so let's get meters down there. Okay, now the last thing is, what do I know about meters? Well, I know that I am 4 times 10 to the 16 meters away, so let's put that in there. Okay, now I got this all figured out, because all the units that I don't need are going to cancel out. Look, I have a meters on bottom and a meters on top. Seconds on bottom and top, minutes on bottom and top, hours on bottom and top, and days on bottom and top. And what's the only unit I'm left with? Well, It's that one unit that I started with, and it's the one that I want. Now, to calculate how many years, this is just a giant division problem, really. So let me write out what this looks like mathematically. It looks like this: 4 times 10 to the 16, that's a 10, over 365 times 24 times 60 times 60 times 3.0 times 10 to the 8th. Now, in class I worked this all out numerically. I'm not going to do that for sake of time, but know this: if you're going to go put this in your calculator, you need to put parentheses around this top number, and you need to put big parentheses around everything that's on the bottom. When you put this divided by all of this, there's got to be parentheses in there or you're going to get the wrong answer. The answer you should come up with is approximately 4.2 years. Depending on how you do it, you could get up to like 4.4 or 4.1. You know, depending on whether or not you use one significant figure, two significant figures. For those of you guys in chemistry, there's some variance in your answers, but somewhere around here is what you should get. If you get, you know, thousands of years or some really big number or some really small number, then you probably did something wrong. Okay, I'm going to define these terms, and then I'm going to finish this part of the video for now. So, polynomial, this is a monomial, or, that's AL, or a sum of monomials. Okay, remember that a polynomial is either a monomial or a sum of monomials. So that's important to know. Okay, like terms is something that we should already know, but these are terms with the same variable to the same power. A trinomial, this is a polynomial with 3 unlike terms. Okay, so 3x squared plus x and negative 5, those are 3 terms that are not alike. And a binomial, this is a polynomial with 2 unlike terms. So you have an x and a 5, they're not alike, you can't combine them other than the way they're already combined. Alright, I'm going to say that's it for this video, and I'll put the second half of this up shortly.